In this video, we will be taking notes on the congruence theorems that we did in class with the triangle activity with the different colored triangles. Now, in that activity, I gave you different combinations of three measurements of either sides or angles or a combination of both. And some of those combinations guaranteed that triangles were congruent every time, and some of them did not. And that's what we did with the activity when we looked at, other groups and we compared. So today we're going to talk about the theorems or the conditions that are reliable, where they are always going to be congruent. The first one is SSS, which you'll see it written out most of the time, which means side, side, side. And this theorem, make sure you're writing all of this down and drawing the diagrams. I will be checking for that. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So if we can find out or are given that we have three congruent sides in each triangle, then we know the whole triangles themselves are congruent. So we have that with our markings. We have that side AB is congruent to DE because they both have one dash. And we could either be, given it with the markings, or it could be measurements, like it could say 6 and 6, and just knowing that it's the same length. We have side AC, which has 2 dashes, is congruent to DF, which also has 2 dashes. And then side BC and EF are congruent. They both have 3 dashes. So now, once we said that we have those 3 congruent sides, we can use the side, side, side theorem to conclude that the whole triangles themselves are congruent. So that means triangle ABC is congruent to DEF. And you want to make sure when you write down this statement that you have all the corresponding parts matching up. We know that from congruent statements, they have to be in the right order. So once we've proven by side, side, side that the whole triangles are congruent, then I can go ahead and conclude that other parts are congruent also. Like I could say that angle A is congruent to angle D. And I'm just even looking at the congruence statement. I can say that angle E is congruent to angle B. And I could say that angle C is congruent to angle F. And I'm allowed to conclude these 3 after I've proven that the whole triangles are congruent. And knowing that every single part of congruent triangles is also congruent, that is called CPT. Congruent parts of congruent, I always forget this. Congruent parts of congruent triangles are congruent. CPCTC. Just know when you see that, that means that if triangles are congruent, everything about triangles are going to be congruent. So yes, we were given that these 3 sides were congruent, and that's what we needed to prove the triangles themselves were congruent. But then we can say everything else, including the angles, is congruent. The next one is side, angle, side. Remember that it's really important when you say side, angle, side, that means the angle is actually in between the 2 sides. It's different than SSA, which isn't even a reliable condition. So if we have side, angle, side, that means 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle. And when we say included, we mean in between. So if we have this, then we know the triangles are congruent. So we've shown that MP is congruent to RS. We have that angle P is congruent to angle S. And we have that PN is congruent to SQ. So once we can, we're given those 3 things, or we might need to find them out on our own, but here we're just given them. Once we have those 3 things, we can say by SAS that triangle MPN is congruent to triangle RSQ. So once I know the whole triangles are congruent by CPT, Let me write it out. Congruent parts of congruent triangles are congruent. CPCTC. By CPCTC, we can say everything else is congruent. So that would include angle M being congruent to angle R. I could also say side MN is congruent to side QR. I want you to think about which angle would be congruent to angle N. And you're going to answer that in the quiz. Just use the congruence statement there. Okay, so now we get to angle, side, angle. Just like the last one where we had side, angle, side, when we have S listed in the middle, this needs to be the included side, or that side needs to be in between the two angles. So if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the whole triangles are congruent. So we have that angle C is congruent to angle F. We have the included side that CB is congruent to FE. And then we have angle B is congruent to angle E. So using angle, side, angle, we can say ABC is congruent to DEF. I want you to now write out all the other parts that are congruent. If we know the whole triangles themselves are congruent, then we can say all the other parts that are congruent. So you need to know what is congruent to angle A, which we didn't use in our proof. What is congruent to side AC?